A great evening. I hope you are well. So I just want to explain in short terms this electrostatic topic. Let us now first think of an atom. An atom has the following things. It has nucleus. It also has what you call neutrons, and the neutrons, they do not have a charge. It also have what we call the protons. The protons are positive. They have positive charges. Also have electrons. Electrons have a negative charge. So now let's draw another atom. We have this atom, nucleus, protons, neutrons, electrons. Now here we have two protons, two electrons, two protons, two electrons. So now it's going to be 2 protons minus 2 electrons, which will give us 0. The thing applies here, 2 protons minus 2 electrons, they give us 0. It means if we have 2 atoms with the same number of protons and electrons, there won't be a charge between these 2 atoms. But let's do this. Let's say now we have what? Yes, we have something like this, and then here we have extra 2 electrons. Now, so for the charge of this atom, charge of this atom is going to be how much? 2 electrons, 2 protons minus 1 electron, which will give us a charge of 1. And then of this atom, the charge that we will have will be 2 protons minus 4 electrons. Then we will have a negative 2. So now it means here a charge of negative 2 will be applied. Therefore, because of these answers, it shows that there will be a charge exerted between these two atoms. And also you can see that even the signs are different. So when the signs are different, we know that these two charges, they're going to attract each other. If it was negative here, we're going to say these 2 atoms are going to repel from one another. Remember that we say different signs attract each other, or different charges attract each other, and the same signs, they repel one another. So now for this reason, that is why this formula that I'm going to write here was designed in order to calculate for the force. The formula F, which is equals to K charge 1 charge 2 all over R. This is the force. It is the constant that you will be given, and then this constant, it is equals to 9 multiplied by 10 to exponent 9. Then this one is charge 1 and charge 2. This R stands for a distance. And you must always remember that the charges they must always be in coulombs, which is a capital letter, a letter C. And by so doing, I'm saying it should be 3C, for example. If it is written 3 small letter n and c, it means you have to convert it to coulombs. And also the distance, the distance r should always be in meters. R should always be in what? In meters. And once again, the most important thing is that even if you are given a negative charge, when you substitute here, you don't include the negative sign. You just include the number, but not the negative sign. Remember that the negative sign, if you include it here, you're going to have a negative answer, and now we don't have a negative force. Let us try and make an example. Let's say you are given two forces like this. Let's say you are given two forces. Let's say you're given two forces, this one and this one, and then you are given that this is 3c, then minus 2c, and then the distance between it is 3 meters. So now it's easy. You're going to use this formula. F is equals to k q1 q2 all over r squared. And then what you do here, you just substitute. It's gonna be 9 exponent 9 multiply by 3 multiply by 2 all over your r is gonna be 3 meters. Some students, they forget to put the square, so it's gonna be squared. And then now your answer, it will be 6 exponent 9. But now here, because of the answer is positive, we don't say to right or to left. We say it is attract. They are attracted to one another. So now this is how you do you do the calculations. So now one might ask, so say, how do we convert if we are not given the charge in coulombs? It's easy. They will give you either 3 small letter m c. They will give you, it is microcoulomb, 3 small letter n c. The nanocoulomb, 3, I don't know what is called this, c. And then 3 the picocoulomb. Now, how do you convert this? For this one, you're going to say, you're going to multiply it by 3 multiply by how much? By 10 exponent minus 3. This one is going to be 3 exponent minus 6. This one is equals to 3 exponent minus 9. This one 3 exponent minus 12. But in most cases, they usually use this and this. So every time when they give you your charge as a nano, you know that you're going to have to include this this exponent minus 6 part. Then you have converted it to what? To coulombs. Now it will be coulomb, coulomb, coulomb. Then you can substitute it as 3 exponent minus 6 coulomb. I hope I made it to be understandable. Thank you.